Absorbent is necessary within an anesthetic breathing circuit during low-flow anesthesia. Expired gases are then rebreathed by the patient. Known as low-flow or circle system anesthesia, its main attraction is reduced consumption of vaporous anesthetic agents that are dosed into the system as a percentage of fresh gas flow and are an expensive commodity. The absorbent isn't replaced until exhaustion is indicated by capnography, typically when inspired carbon dioxide exceeds 0.5% of the inhaled gas volume. The absorbent's only role is to absorb carbon dioxide. It should be compatible with the anesthetic vapor and under no circumstances interact with the vapor to produce chemical degradants. Other than Amsorb Plus, commercially available absorbents are mostly sodium hydroxide based, known as sodalimes. It's these absorbents that are commonly associated with breakdown of the anesthetic vapor and patient safety issues. Development of low-flow anesthesia has been complicated by poor absorbent performance and the necessity for extensive patient monitoring. The inability of absorbents to ensure safety has impacted on the perception of low-flow anesthesia as a viable and safe technique. The unpredictable behavior of sodalimes and barolime, as well as the widespread reporting of clinical incidents associated with their use, has led to uncertainty. Not knowing when absorbents are desiccated and hence potentially dangerous has led many physicians to look for alternatives. Some absorbents are known to degrade anesthetic vapor into potentially toxic compounds, of which carbon monoxide, methanol, formaldehyde, dimethoxymethane and compound A have been reported, along with related adsorption or disappearance of anesthetic vapor into desiccated absorbent. Carbon monoxide is an innocuous toxin, a silent killer with an affinity for hemoglobin greater than oxygen. A long half-life makes it resistant to displacement from hemoglobin. Formaldehyde is more obvious. It's a potent respiratory irritant and carcinogen. These degradants have no role to play in anesthesia other than posing risk to patients. Amsorb Plus has been developed to eliminate these problems. Amsorb and its second-generation product, Amsorb Plus, were developed in 1997 and 2002 respectively, in collaboration with the Queen's University Belfast. A proliferation of clinical reports and near-death incidents with conventional absorbents prompted the inventors to reformulate an absorbent without the strong chemical base of sodalimes, which were known to cause destruction of the anesthetic vapor to carbon monoxide. Amsorb Plus became the solution to a real clinical problem. It's incapable of degradation of anesthetic agents in any state of use. It simply absorbs carbon dioxide. Over 170 papers have been published on the performance of absorbents in the presence of anesthetic vapor. Many discuss the unpredictable nature of absorbents and their ability to produce toxic levels of carbon monoxide. Previously, nothing was known about the ability of absorbents to degrade sevoflurane. The Cannizzaro reaction characterized the transhalogenation of sevoflurane to compound A and compounds B to F, while in the presence of fresh or desiccated sodalimes. Compound A has been shown to be nephro- and hepatotoxic in rats. Production of carbon monoxide from exposure of isoflurane, N-fluorane and desflurane to desiccated absorbent was first described amid suggestions that, such was the seriousness of the problem, the anesthetic agents should change rather than the formulation of the absorbent. ECRI, the safety organization, issued hazard alerts on the use of absorbents, and many eminent authors discussed measures to limit the danger to patients. But it wasn't until Murray first described Amsorb in 1999 that users had a viable alternative to sodalimes and barolime. In the same journal, Professor Dr. Evan Karash described the invention as elegant in its simplicity. More ECRI warnings followed, along with clinical reports supporting the use of Amsorb. Regrettably, serious clinical incidents continued, some involving combustion of absorber canisters, in which sevoflurane is thought to have reacted with desiccated absorbent, producing carbon monoxide, methanol, formaldehyde, and heat, preceding explosion and fire in the absorber. In conjunction with an alert issued by FDA MedWatch Safety Information and Adverse Event Reporting Program, Abbott Laboratories, the manufacturers of ultane sevoflurane, reported in a letter in November 2003 that clinical adverse incidents are possible, in which sevoflurane could react with absorbents, creating extreme heat, carbon monoxide, methanol, and formaldehyde. An earlier study by Holak at the University of California warned of the potential for this occurrence and demonstrated the conditions under which the absorber canister, gas, and related apparatus would self-combust. Finally, the APSF, Anesthesia Patient Safety Foundation, convened a conference of invited medical experts and absorbent manufacturers in which a consensus statement was reached, suggesting that absorbents that significantly degrade anesthetic agents should not be used. Amsorb Plus does not contain strong base chemicals common to other absorbents. Instead, the absorption accelerant is calcium chloride. Consequently, Amsorb Plus is completely inert in the presence of anesthetic agents. Its color indicator responds to desiccation without requiring the presence of carbon dioxide. Granule diameter and length are constant, and special production controls limit the presence of dust. Simulated clinical testing is used to qualify each production lot prior to release. The product is available in a variety of loose-fill packages and pre-packed canisters. Unlike sodalimes, Amsorb Plus is not caustic and can be handled and disposed without special precautions. Amsorb Plus is clinically proven to prevent degradation of inhalational anesthetic agents to carbon monoxide, methanol, formaldehyde, dimethoxymethane or compound A, and to have minimal adsorption or disappearance of the anesthetic vapor into desiccated absorbent material. Amsorb Plus has a gradual and permanent color change to indicate loss of absorption capacity and the extent to which it has become dehydrated. The color change mechanism of Amsorb Plus is triggered by dehydration of the material, either from the drying effects of gas flow or from carbon dioxide absorption. It's therefore important to switch off gas flow during periods of non-use to optimize the absorption capacity.
Assalamualaikum warahmatullahi wabarakatuh. Pada hari ini, saya akan sedikit menjelaskan tentang sodalime. Sodalime adalah suatu bahan kimia yang berfungsi untuk menyaring atau memisahkan CO2 dengan gas murni O2. CO2 yang diekspresikan oleh pasien kembali masuk ke mesin anestesi dan disaring oleh sodalime itu tersendiri. Sedangkan gas murni O2 dan agen volatile kembali lagi pada saat pasien melakukan inspirasi. Untuk membuka tabung sodalime, kita memutar tabung ke arah kiri berlawanan dengan arah jarum jam. Beberapa karakteristik sodalime diantaranya adalah dengan terjadinya perubahan warna dari berwarna pink ke warna putih. Dan juga dapat dilihat dari segi kekerasan sodalime itu tersendiri. Jika beberapa karakteristik sudah terpenuhi, maka kita harus segera menggantikan sodalime agar mencegah pasien keracunan CO2. Untuk memudahkan kita mengingat dan melakukan penggantian sodalime secara teratur dan terjadwal, kita bisa menggunakan media stiker sebagai berikut. Cara melakukan pengisian pada stiker. Pertama, tuliskan bulan saat melakukan penggantian. Kedua, seperti keterangan, kita memberi tanda lingkaran pada tanggal penggantian. Contohnya, kita melakukan penggantian pada tanggal 2. Selanjutnya kita bisa menjadwalkan penggantian untuk 7 hari ke depan, yaitu pada tanggal 9 Agustus. Dan jangan lupa mengganti tahun saat pergantian tahun. Selanjutnya, setelah mengganti sodalime, kita pasang kembali tabung pada mesin anestesi dengan mengikuti arah jarum jam. Stiker yang sudah kita isi, kita tempelkan pada tabung, agar teman yang lain yang bertugas dapat melihat kapan terakhir sodalime ini sudah diganti dan kapan penggantian selanjutnya.